Let's talk about immunotherapy. For years, it's been a total game changer in the world of cancer treatment. But what happens when these amazing, life-saving drugs just stop working? It's a devastating moment for so many patients, and honestly, it's one of the biggest challenges in oncology today. So in this explainer, we're going to break down what happens next.
Yeah, this is the question, isn't it? The one that keeps doctors, patients, and their families up at night. You have a treatment that was doing its job, holding the cancer back, and then it just fails. The cancer starts growing again. This isn't just a small setback, it's a massive turning point where the very next decision could change everything.
So to really get to the heart of this, we need to zoom in on a specific battleground. We're going to focus on a common type of lung cancer, where this exact problem, treatment failure, is a huge hurdle that everyone is trying to figure out.
Okay, so the official clinical term for this problem is acquired resistance. Think of it like this. Your body's immune system is like a fortress that's been successfully fighting off an enemy. But the enemy, the cancer, is smart. It learns, it adapts, and it figures out a new way to get past the walls. That's exactly what's happening. For patients with what's called non-small cell lung cancer, their tumors, which were shrinking or at least stable, suddenly start to grow again. And that leads to the crucial question, what on earth do you do now?
Well, when that first line of defense fails, doctors are basically standing at a fork in the road. They have to make a choice. And there are two main strategies they can turn to, each with a completely different philosophy for how to fight the cancer.
So, down one path, you've got the old, reliable, the established workhorse, platinum-based chemotherapy. This is a powerful strategy that's been around for decades, and it works by just attacking any cells that are dividing rapidly, which is, a classic feature of cancer. Then, down the other path, you have a different flavor of immunotherapy, something called CTLA-4 inhibition. Instead of going after the cancer directly, it tries to re-energize your own immune system by essentially cutting a different set of brake lines that are holding it back. So two totally different approaches, and until now, no real solid data on which one is the better choice.
And that is exactly where this groundbreaking study comes in. This is the whole focus of our explainer today. For the very first time, a study has put these two distinct strategies head-to-head. And, this is the kind of research that can really truly change how decisions are made in clinics all over the world.
And I want to be really clear here. This isn't just another small, incremental update. The researchers behind this knew that doctors on the front lines needed answers, and they found a really innovative way to get them by looking at data that already existed, but in a totally new way.
What makes this so special? Well, listen to how the researchers themselves put it. This is the first study to systematically and quantitatively compare these two treatments. In other words, this isn't just someone's opinion or an educated guess. It's about filling a huge gap in our knowledge and finally using hard data to find some answers.
So you're probably wondering, how did they compare these treatments without running a brand new, years-long clinical trial? Well, this is where it gets really, really clever. They use some pretty sophisticated statistical methods to basically reverse engineer patient data from studies that had already been published. Imagine trying to build a really complex Lego model just by looking at pictures of the finished thing. That's kind of what they did here, but with data. And it allowed them to pool all this information together to get a much bigger, clearer picture.
Of course, no single study is ever perfect. That's just not how science works. And a huge part of great science is understanding both what a study tells us and, just as importantly, what its boundaries are. So let's take a really balanced look at the strengths that make this research so powerful and the limitations we absolutely need to keep in mind.
Okay, so what makes this study such a big deal? First off, its scope is massive. By pulling together data from a bunch of different trials, it gives us a much stronger signal, a much clearer answer than any single study ever could. It also goes right after that critical, unanswered question about acquired resistance. And maybe most importantly, its findings aren't just academic. They provide real, actionable information that oncologists can think about using in the clinic, like today.
Now, on the flip side, we have to be totally honest about the limitations here. Because the data was reconstructed, it's a really powerful estimate, but it's not quite the same as having the original raw patient data. Plus, you're mixing and matching different studies, which means the patient groups weren't all perfectly identical. So we should see this as a very, very strong clue, but it's not the absolute final word that a brand new, forward-looking clinical trial would be.
So what does this all mean for the future? Well, a study like this is fantastic because it doesn't just give us answers, it actually illuminates the path forward. It tells us exactly what questions we need to be asking next in the fight against cancer.
And what's great is that this research provides a super clear roadmap for what needs to happen. First, we need a new, dedicated, head-to-head clinical trial to confirm these findings with the absolute highest level of evidence. At the same time, the hunt is on for biomarkers, those little biological clues that can help us predict which patients will do best on which therapy. From there, you explore new combinations, and, ultimately, you have to validate all of this with data from thousands of real-world patients. It's all about pushing us closer and closer to truly personalized cancer care.
So, after all that innovative data analysis, what did the study actually find? Well, the data strongly suggests that for these patients, sticking with a different kind of immunotherapy may actually be a better path forward than switching over to traditional chemotherapy. And that is a huge piece of the puzzle. It shows that by creatively using the data we already have, we can find answers that make a real difference. And it leaves us with this one critical question. How can we keep using smarter data to finally stay one step ahead of a disease that's always evolving?